Okay, welcome to ShreeKrishna educational channel. Please like, share and subscribe my channel. In this video I am going to explain about the chemical properties of the phenols of class 12th chemistry, alcohols, phenols and ethers. First, the acidity of phenols. Okay, when the phenols which are treating with the blue litmus paper, it turns into red color. Similarly, when the phenol which is treating with the most reactive metal like sodium, so it forms sodium phenoxide and releases hydrogen gas. And when the phenol is treating with the sodium hydroxide, so that case it gives sodium phenoxide plus water molecule. So this indicates the neutralization reaction. But when the phenol which is treating with the sodium carbonate, so that case you do not respond with the sodium carbonate. So it means, so it is a weak acid. So this acidity of the phenol, which is due to the polar OH bond present in the case of the phenol. And the phenol which is treating with the aqueous solution, that is a water medium, so that case it gives the phenoxide ion. And alcohol which is also treating with the water, so that case it gives the alkoxide ion and hydronium ion. So among these phenoxide ion and alkoxide ion, so which is more stable, and in addition to that among the alcohol and phenol which is having the more acidic nature. So if we consider these alcohol and phenol, so among these the alcohol which forms the alkoxide ion and the phenol forms the phenoxide ion. So among these the alcohol which forms the alkoxide ion, but the alkoxide ion which do not undergoes the resonance, whereas the phenoxide ion which can undergoes the resonance. So due to the resonance, the stability of the phenoxide ion which is more, so it can be easily lose this proton in the case of the phenol. But whereas the alcohol, that possibility which is not present, so the stability of the alkoxide ion which is less than that of the stability of phenoxide ion, so that the acidic nature of phenols which is more when comparing with that of the alcohols. Next, the acidity in the case of these phenols, the oxygen consists in the pair of electron, so it can be delocalized towards the ring. So that case the oxygen and carbon of the benzene ring which can get the multiple bond, and oxygen gets the positive charge. Next, then the negative charge which can be observed on the carbon, so which can be delocalizes, so it can be forms the another resonating structure, that is the para position, it gets the negative charge, and the multiple bond can be observed between the second and third carbon. So now the negative charge which is delocalized between fourth and fifth carbon, so that case the double bond between fifth and sixth carbon can be moved towards the sixth carbon. So the double bond can be obtained at fourth and fifth carbon, and the negative charge which is present on the sixth carbon. So when this negative charge which is delocalizes, then the double bond between the oxygen and first carbon which can be moved towards the oxygen. So the negative charge of the sixth carbon which can be converted in the form of the double bond, and the positive charge present on the oxygen which is removed by the taking the double bond towards the oxygen. So as a lone pair can be obtained on this oxygen. So now in this case the phenolic resonating forms, so the three cases, second, third and fourth cases, the oxygen and the carbon, it has a double bond, and at the same time oxygen has the positive charge on these three cases. The first and fifth case, the oxygen doesn't have any positive charge. Next, the stability of the phenoxide ion if you see, so when the alcohol which is undergoes the removing of the proton, so that case it gives the alkoxide ion and releases the proton. And the phenol which is releases the proton gives phenoxide ion. So now the phenoxide ion, if we see the phenoxide ion which is undergoes the resonance, so that case the double bond which can be observed in the case of the three cases, first, second, third and fourth. these three cases, the double bond present between the first carbon and the oxygen, okay, and the oxygen doesn't have any charge in these three cases. Okay, so the oxygen which is more stable. So the phenoxide ion, which is a highly stable than that of the phenol. So in the case of the, when it is treating with the hydronium ion, so it forms the phenol, that a reverse reaction phenol which can be possible very less easily than that of the alkoxide ion when it is treating with the hydronium ion. Okay, because the concentration of H3O plus, okay, which is higher in the aqueous solution of phenol than the aqueous solution of alcohol. So therefore, the aqueous solution of phenol which is more acidic than alcohols. So this is the acidity of the phenols. When the phenol has any of the substituents, so that case the acidity that should become varies. Suppose orthonitrophenol which is having the pK value 7.2, metanitrophenol pK value 8.3, paranitrophenol pK value is 7.1, phenol is 10.0, orthocresol 10.2, metacresol 10.1 and paracresol 10.2. Ethanol which is having the 15.9, so that is the pKa value. So among these, ethanol has more pKa value and paranitrophenol has the less pKa value. So with respect to the pKa value also we can mention the acidity, that which has the less pKa value that has more acidic nature. So in this case the ethanol has more pKa value. Okay, so that means it is having the less acidic nature. So the paranitrophenol has less pKa value, means it has more acidic nature. So paranitrophenol has more acidic nature even with phenol, and the ethanol which is having the least acidic nature among these phenolic compounds. So the phenolic compound, if it has the electron withdrawing group at the para position, so that case it's a acidic nature which is more. So because of this reason only the paranitrophenol is having the more acidic nature. Next another reaction, that is the esterification. So when the phenolic compound, that is salicylic acid, which is treating with the acetic anhydride in presence of the mineral acid, that case it gives acetyl salicylic acid, that is also known as aspirin. Along with that it also gives the acetic acid. So in this case the alcoholic group, phenolic group, which is treating with this acetic anhydride and form the ester. Next reaction, that is electrophilic substitution reaction in the case of the phenolic group. So this first one is the nitration, and the phenol is treating with the dilute nitric acid. That case it gives orthonitrophenol and paranitrophenol. So the mixture of compounds can be obtained. So among these the orthonitrophenol and paranitrophenol, orthonitrophenol undergoes intramolecular hydrogen bonding and paranitrophenol undergoes the intermolecular hydrogen bonding. So among these the product, the separation which is difficult, so that case we need to use the fractional distillation, so that the first we can obtain the orthonitrophenol, later we can obtain the paranitrophenol, because orthonitrophenol has the less boiling point due to intramolecular hydrogen bonding, and the paranitrophenol has the more boiling point than the orthonitrophenol, so that is due to the intermolecular hydrogen bonding. Even the phenol which is treating with the concentrated nitric acid, so that case it gives 2,4,6-dinitrophenol. It is also known as the picric acid. So in this case means when it is treating with the concentrated nitric acid, that case the nitro group can be take part at the 2, 4, 6 positions. So that is known as 2,4,6-trinitrophenol, also known as the picric acid. Next, the electrophilic substitution reaction, that is the halogenation. So in the case of this halogenation, when the phenol is treating with the bromine water in presence of the carbon disulfide or carbon tetrachloride, so that case it gives the orthobromophenol as well as the parabromophenol. So this reaction which is carried out at the low temperature, that is 273 Kelvin. So here the orthobromophenol is the minor product and the parabromophenol is the major product. And the phenol which is treating with the bromine water, excess of bromine water, so that case it gives 2,4,6-dibromophenol can be obtained. Next important name reaction, which is the Kolbe's reaction. The phenol which is treating with the sodium hydroxide, so that case it gives the sodium phenoxide. Okay, the sodium phenoxide is treating with carbon dioxide gas, CO2 gas, in presence of H plus mineral acidic medium, so that case it gives 2-hydroxybenzoic acid. It is also known as the salicylic acid. Next named reaction, that is the Reimann-Tiemann reaction. And the phenol which is treating with the chloroform CHCl3 in presence of the aqueous sodium hydroxide, that case it gives the intermediate is initially obtained, so that is as ONA, the OH group can be converted as ONA, and the other position it can be obtained CHCl2. Now this intermediate which is treating with sodium hydroxide, so in case it can be obtained, the CHCl2 group can be converted as CHO aldehyde group, and the ONA which is present on this benzene ring, which is treating with the acid hydrolysis, so that case the ONA can be converted as OH. So and the other position it has the aldehyde functional group. So this is known as the salicylaldehyde. It is also important name reaction. Okay, next the reaction with the zinc dust. When the phenol is treating with the zinc metal, so that case it forms the benzene plus the zinc oxide. So this in this case the removing of the oxygen which can be takes place from the phenol, so this is known as reduction. Okay, reduction means removing of the oxygen, so it is a reduction process. Another reaction, when the phenol which is treating with the sodium dichromate in presence of the sulfuric acid, so that case it gives the benzoquinone. Benzoquinone can be obtained, so it is a oxidation reaction. So the two ketonic functional group which can be observed at the ortho position as well as the first position and the fourth position. And the use of the alcohols, first one is the methanol. Methanol is also known as the wood spirit. Its formula is CH3OH. It can be produced by the destructive distillation of the wood. So when the carbon monoxide which is treating with the hydrogen gas in presence of zinc oxide and Cr2O3 at high pressure, that is 200 to 300 atmosphere pressure, and the temperature is 573 to 673 Kelvin. So that case you can obtain the methanol. CH3OH can be obtained. Now the methanol, it is a colorless liquid and it boils at 333 Kelvin. It is highly poisonous in nature. The injection of even small quantities of methanol which causes the blindness and the large quantities which can be even causes the death. So it can be used as a solvent in the case of the paints, varnishes, and which is a cheaply making to prepare the formaldehyde. Okay, this is about the methanol. Next, the ethanol. Ethanol is C2H5OH, its formula. It can be mainly obtained from the sugars by the fermentation method. When the sugar, that is C12H22O11, which is treating with the water, so by the enzyme, that is invertase, so gives the glucose and fructose. Now the glucose or fructose which is treating with the zymase enzyme, so that case it gives the alcohol ethanol plus carbon dioxide. Now this is mainly we can obtain from the wine. So in case of the wine making, so we can get grapes. Okay, when the grapes, which is the main source of the sugar, so and the yeast, okay, which is also present. So that case the grapes which can be ripen, the quantity of sugar that should become increases, and the yeast which can be grows on the outer skin, and these grapes are which are crushed. So that case the sugar and the enzyme come in contact, and the fermentation, that process that should become starts. The fermentation takes place in the anaerobic method, means that is in absence of the air. So this reaction which is carried out, and during this case the carbon dioxide gas which is released. So the action of this J-mage is inhibited once the presence of alcohol is formed, okay, exceed 14%. If air gets into fermentation mixture, so that case the oxygen of air which is oxidize the ethanol to ethanoic acid, so which turns the destroy the taste of the alcohol drinks. So the ethanol, which is a colorless liquid, it boils at 351 Kelvin. So it is used as a solvent in paint industry, and it is in the preparation of the number of carbon compound. That case we use ethanol. The commercial alcohol, okay, which is made unfit for drinking by mixing it some amount of copper sulfate and the pyridine. Here the copper sulfate gives the color to this alcohol, and the pyridine gives the foul smelling. So that is unfit for the drinking. So this process is known as denaturation of alcohol. Nowadays we are mostly getting the ethanol by the hydration of the ethene. When the hydration of ethene, that case we can get the ethanol. So this is about the use of alcohols and chemical properties of phenols. Thank you.